Why did you want to be an astronaut?
When I was 5 years old, I saw on the Japanese TV program that Armstrong and Aldrin landed on the surface of the moon, and that was the start of my longing for space flight. However, at the time, there was no Japanese astronauts in my home country, and only American astronauts and former Soviet Union cosmonauts were the only people who were working outside our home planet. So I thought going to space was something really beyond my reach. And I was very fascinated by airplanes ever since I was a small boy. And I always wanted to become an engineer or pilot to make and fly an airplane. And that's what I aimed for a long time since my childhood. Studied aeronautical engineering and became an engineer. And then after that, Japanese Space Agency had a selection of astronaut candidate that was back in 1991, and I found that article in the newspaper, and at the time my old dream of flying in space came back when I saw the article, and of course I never dreamed or thought of getting selected. But I was just lucky, and then I made it in, and I'm here now.
I want to talk more about now, but I want to talk about how you got to here.
Okay.
Let's talk about growing up in Japan, your hometown, and what it was like growing up there at the time.
I was born in a city at the time called Omiya. Now it is called Saitama. And that town is located about 30 miles north of downtown Tokyo area. And it is what we call bed town of Tokyo. It has a combination of the small town Japan flavor and also the big city of Tokyo. And I grew up there, went to school, elementary, junior high school, and high school, and has a lot of housing and beautiful nature as well. And it was one of the places that I like in Saitama is a shrine called Hikawa Shrine. That is located in nearby the center of the city of Omiya or Saitama right now. It's a quiet place with a beautiful pond, and it always gives me a feeling of being at home when I visit the shrine. And that's where I grew up, and I stayed there until I graduated from high school.
It sounds like it may be similar to an American suburb.
In a sense, yes. It's a very crowded area. Tokyo is a really big city, and a lot of people live outside the outskirts of Tokyo to commute, mostly by train system. And so a lot of people living in that area, too.
Were you able to pick out Saitama from space?
Actually, I took a lot of pictures of Tokyo area, and I was able to find my own hometown through the scope of a camera. And it's always a wonderful thing to be able to take a picture of your hometown. First time, I tried to take a picture of my hometown, and then a few days later, I tried to take a picture of entire Japan, and then after that, I tried to take a picture of Asia, and then soon I'll be taking pictures of our home planet in general. So it's very interesting to see the change in the scope as the days pass by living on board a space station.
You mentioned that you grew up in this area just outside Tokyo and then went to university and ultimately became an astronaut. What are the highlights of that story, of your education and your professional career that led you to this spot?
Ever since my childhood, I was fascinated with the airplanes. I wanted to become an engineer on an airplane. And I studied aeronautical engineering at the university in Japan. And actually, it was when I was in the junior in the university, I witnessed some of those catastrophic airplane accidents that were due to the failure of airframe or the structure of the aircraft. And I noticed how difficult it is to safely operate airplanes. And at the time, I decided I wanted to be an engineer in the structural and the strength of airframe. And that's what I studied in my undergraduate and also the graduate school, to be able to become a structural engineer in airplane engineering. And after finishing my master's degree in Kyushu University, I joined the Japan Airlines as a structural engineer. And later on, I received PhD from the university after I joined the astronaut program here. But that's the job that I had before I applied for astronaut selection.
So you were already working for your nation's space agency before you were selected to be an astronaut yourself?
Actually, I was an engineer of Japan Airlines for 3 years before I joined the Japanese Space Agency. That was back in 1992. The selection process of an astronaut started in the summer of 1991. And we went through academic exams, medical, psychological screening, also some group dynamics assessment. And 9 months later, after five stages of screening, I was selected to join here in the astronaut training course at the Johnson Space Center. That was in the summer of 1992.
You're one of, actually at this point, only a little more than 200 different human beings who have ever been on board the International Space Station, at least so far. And as you get ready to go back, what are your hopes about how you can use this mission to inspire space explorers of the future?
I hope through our activities on board the space station, we will be able to enhance the interest among the youngsters, especially in science and technology. And this is an important part of our daily life, to make our living on the ground on Earth better, and contribute to create a peaceful society and the world. So I am very anxious to be able to contribute to, especially to the young generation, to enhance their interest in science and technology through this mission.
When you fly in space, you are doing a part of the astronaut's job that has some risks that are different than what most people experience in their jobs. And yet, I assume that you think that it's worthwhile because you're doing it. Tell me what it is you think that we are getting, or what is it that we learn from flying people in space that makes the risk worthwhile?
Any explorers need to take a risk associated with the exploration. And space is part of that. I think we can gain new knowledge, new technologies that we benefit in our daily life on the ground by going to space. And also, I strongly believe human space program is a vehicle for the survival of human species. So, of course, going to space is a risky activity, but the gain or the benefit that we get through this human space exploration is beyond the risk that we take in the effort.
Koichi, you and your crewmates are next in line to launch to the International Space Station. What are the goals of your flight this time, and what are your jobs going to be on this mission?
We're Expedition 38 and 39, launching on the Soyuz TMA-11M spacecraft. During the 6-month stay on orbit, we will be conducting scientific experiments, engineering experiments, doing educational programs, and also we will be receiving different cargo supply ships from Russia and from the United States. The U.S. commercial spacecraft that we will be seeing on board is our SpaceX Dragon, orbital Cygnus, and from the Russian side we will be expecting to receive a few Progress cargo ships. In addition to that, from the Russian side, we will be receiving a multi-purpose laboratory module, MLM. That's a new module that will be attached to the nadir side of the service module. So we will be conducting a lot of scientific experiments. In addition, we will be receiving many visiting vehicles. So it will be a very exciting and very busy mission. And during Expedition 38, I'll be working as a flight engineer of the International Space Station. And during Expedition 39, I'll be serving as the crew commander.
You're going to be the first Japanese astronaut to be commander of the International Space Station. I take it that that's drummed up a lot of excitement in Japan to have a Japanese astronaut to be the commander.
Yes, ever since the Japan has been involved in the International Space Station program, we worked hard, and JAXA launched the Japanese logistics module, experiment module. Those are the Kibo module of the International Space Station. And the launch of the Kibo module started in 2008. And since then, Kibo module has been working without a big problem, and it has been producing a lot of scientific research results. And also, just recently, the Japanese Konotori spacecraft, that's a HTV cargo supply vehicle launched from Tanegashima Space Center. It was deorbited. It will be deorbited this Saturday. But this is the 4th launch of the Japanese Konotori spacecraft. And the first launch was in 2009. And since the first launch, Konotori has successfully launched the cargo and supplies to the International Space Station. So looking at the Kibo's performance and Konotori's contribution, Japan has become a very reliable partner of the International Space Station program. And as a partner of the International Space Station program, Japan will be happy to see its own representative to command the space station. And I am just very fortunate to be able to serve as the Japanese first space station commander.
You mentioned a couple of historical things. You're going to be in space around the 15th anniversary of the launch of the first element of the space station, the Zarya module. What do you think about what this station has become in 15 years since that's happened?
Yeah, space station is an amazing outpost to expand from human frontier in space. And I was involved in the design and development of the International Space Station software and hardware, especially for the Japanese Kibo module. And also I was involved in the assembly tasks of the International Space Station on actually 3 different space shuttle missions. So it's wonderful to see that the station has become such a wonderful scientific lab. And I'm so glad now to see that the station is in the stage of full utilization, conducting a variety of experiments in science and technology, educational programs, observation of in astronomy, and also the Earth observation. So, and it's all conducted in the spirit of partnership. So I feel a sense of fulfillment that station has become this matured stage of full utilization.
Let's talk about that for a second, because the science that you do on board the station has really become the focus of what crews are doing now, since most of the assembly is over. How do you convey to people the potential for what we can learn from flying people on board this vehicle?
By conducting a variety of scientific research, scientists have been developing new technology in the various fields in science. For example, in medicine, through the protein crystal growth experiments of utilizing microgravity, the scientists are already in the stage of developing like new medicines, such as for muscle dystrophy, and also some medicine that can cope with the different strains of influenza viruses, for example. So by conducting research or experiments on board the space station, we are gaining a lot of new knowledge and technology that we all can benefit on a daily life on the ground. And also, if you look into the future, I believe human space program is a vehicle for the survival of a human species. Recently, we had seen the a meteor coming into the atmosphere over Russia, and I think it is just a matter of time before a large meteoroid could hit the Earth, and also in 5 billion years we will be seeing the loss of our own sun. So by exploring the human frontier in space and trying to develop a technology to make a home away from home is really an important action on humankind to survive as species. And that's one of the most important part of our program in the human space program.
One of the big areas of the research that's done on board is to find out how being in that environment for a long period of time impacts the people who are doing it. As a matter of fact, the partners have picked a couple of crew members that they're going to send to space for a full year to try to gain more data for that. What are your thoughts about the idea of going to space for a full year?
Space station is an excellent test bed to understand the effects of microgravity, to live in space for an extended period. Going to Mars would probably take 2.5 years as a total duration of flight. And there are a lot of issues that we need to resolve before we sending humans to Mars. So by having longer duration, such as 1 year on board the space station, we will be able to acquire new knowledge about the effect of microgravity on the human physiology. And by gaining this new data and knowledge of the effect of the microgravity on a longer duration flight than the conventional 6-month stay, we will be able to better prepare for the missions beyond low Earth orbit, such as to Mars.
Would you like to go for a year yourself?
Yeah, if I were given the opportunity, I would definitely go. And I'm sure it's going to be a challenge, but that's what we do, and we do love taking the challenge.
Now, you've been to space, as we said, on shuttle missions for relatively short periods of time, plus an extended trip as a member of the space station crew. So from the perspective of somebody who has been off the planet and experienced the effects of being off the planet for a long period of time, what areas would you say we really need to focus on in order to maximize the chances of successful missions to Mars or long missions way past Earth?
Needless to say, I think it's very essential to enhance the safety and the reliability of the systems that we use for our space flight. And also, it's important for us, astronauts and cosmonauts, to function well during the flight. There are a variety of medical, physiological, and also psychological issues that need to be addressed before we go beyond the low Earth orbit, such as loss of bone density and weakening of the muscles, and also visual impairment due to the increase in the intracranial pressure. And also on the psychological side, if you are gone from your home for 1 year, it will be very important to have the stability psychologically as well to serve with a full capacity as a crew member. So there are a lot of things that we need to find out and resolve before we send humans to Mars. So I think this 1 year mission, through these missions, we will be able to acquire new knowledge and data to be better prepared for those missions.
And of course, that's a big focus of the science that will be done on your mission this time around. Give me 2 or 3 examples of human life sciences research and experiments that you're going to be involved with on this flight.
As a matter of fact, I will be involved in 17 different scientific experiments as a test subject on human physiology. And so it'll be a very busy mission for me, being a test subject in different experiments. Some of the examples are like I'll be participating in an experiment called a SPRINT experiment. SPRINT is a newly developed exercise protocol utilizing like a shorter but the high intensity exercise using the resistive exercise device. And also on the aerobic side, using a treadmill and also bike machines, we will be conducting an experiment with higher intensity and then also like a intensive interval training type aerobic activities. With this protocol, we can reduce the number of actually hours of exercise on board the space station with expected similar results to maintain the bone density and the strength and muscle. So that's one of the examples that could help to better prepare for a longer flight like to Mars. And also, as part of the Japanese experiment, I'll be a test subject of a new exercise device called hybrid training equipment. That equipment is to utilize the electrical stimulation for the exercise, resistive exercise. And since that uses electrical stimulation, the device is very small. It's much smaller than the conventional resistive exercise device that we use on board right now on the station. So hopefully that kind of technology will give us like a compact exercise device that could fit in a smaller spacecraft that may be used for future flights to the moon or Mars or asteroids. So those are some of the examples. And also from European Space Agency, I'll be a test subject on the experiment called circadian rhythm. And through the training and also through the space flight, that experiment is gathering data of our circadian rhythm related data, such as change in the body temperature and in this non-24-hour day-night cycle, and also in a closed environment and differently controlled schedule of the tasks compared to the ground. So circadian rhythm data will give us some insight also to be able to better prepare for longer duration flight. And some other examples will be ocular health. That's a NASA research that I'll be participating as a test subject. In that research, we will be measuring our physiological data related to the changes in the eye and the brain due to the change in the intracranial pressure in the microgravity. And by consistently gaining or measuring this kind of physiological data on our eyes and brain, we will be able to find out exactly what other causes are for the eyesight change in flight. Maybe we can come up with countermeasures to cope with the situation. So those are some of the examples of the physiological experiments.
Those are good examples of the variety of human life sciences experiments, but that in itself is only one area of the science research. You've got laboratories on this station filled with equipment to do research in other disciplines. Give me a few examples of some of the other kinds of science that you and your crewmates are going to be busy with.
Yes, I will also be involved in a variety of experiments, such as in the fluid science. One example will be a Marangoni experiment. In a fluid, there's a surface tension, and the surface tension actually varies depending on the temperature of the fluid surface, and also depends on the concentration of the dissolved matter on the surface of the liquid. And if there's a difference in the surface tension, it will create a convection that is called Marangoni convection. And it's really difficult to see that in the 1G environment on the ground, but it's very easily observed in the microgravity environment. And the Marangoni convection actually causes a negative effect when we try to create silicon crystallization in microgravity, and also on the ground, for example, for the heat pipe devices that we use in the microcomputers, laptop computers. So Marangoni convection causes some adverse effect in those heat pipes radiation. So by conducting the experiments in the Marangoni convection, we will be able to gain knowledge, insight of this fluid activities, so that we can utilize the design, the data to design a better heat pipe for better heat radiation capabilities, for example. And that's one example of the fluid science. And I'm also involved in the ice crystal experiment. It is an experiment to observe the phenomena or the behavior of ice crystal growth in microgravity. If you use supercooled antifreeze protein solution in the experiment, actually that freezing process could be inhibited by the adsorption between the ice and the water surface. And the outcome of this experiment could lead to improve, for example, the taste of frozen food. And also in the field of live organ transplant, if you could find a way, develop a technology to do the organ transportation without freezing the organisms, that could be a new technology in the field. So this ice crystal experiment could lead to insight in the new technology in those fields. I think those are some of the examples of fluid science.
There's a lot of different kinds of science that you guys are going to do, and yet the science work on board is not the only thing that you do during the time that you're there.
Right.
Can you give us a sense of maybe what is if there is such a thing, what is a normal day like on board the International Space Station? What kind of things do you do outside of the science work?
Actually, it's not a day-to-day activities, but the disaster response could be an important part that we could play, utilizing the ISS asset. Disaster could include the earthquakes, tsunami, or hurricane, some other natural phenomena. By utilizing the ISS equipment, cameras, videos, and still photography, we will be able to provide data and information to do those areas of disaster. And that is one important utilization of what we have on board the space station. When it comes to this daily life on board the station, in the morning we wake up and we eat breakfast and take care of our personal hygiene. And then after that, in the morning and also in the evening, we have what's called daily planning conferences with the mission control centers throughout the world, Houston, Huntsville, Moscow, München, and also Tsukuba, Japan. And during the day, we conduct our tasks, assigned tasks. We also do exercise using the bike, treadmill, and also a resistive exercise device. And in the evening, after our work is done, we will have some time for personal activities, sending emails to our friends and family. And also sometimes we use that time to prepare for the next day's task. That's a typical day on board the space station.
Did you find you're able to get into a routine just like on Earth?
Actually, it is very surprising how quickly humans can adapt to a new environment. Whether I go to Russia for training, in a time zone, it takes maybe a few days for getting rid of this jet lag. But it's very similar. When I go to space, for the first day or two, it takes a while for me to situate myself without the gravity and where the restroom is located and something like that. But after that, you will be able to quickly adapt to the new environment. And then as if I'm a fish with the water, for example. Like in a few days, you get used to this new environment and work and live very efficiently.
On this flight, you and your crewmates actually your arrival is going to start an unusual bit of business, because for those first few days, there are going to be 9 station crew members on board, and that's more than is usually the case. Tell me about the excitement that's planned in this first week or so of your flight, and what's going to happen on the station while there's so many people there.
Yeah, of course, when it comes to the number of crew members, the more the better, and the more the merrier, I would say. So I'm very much looking forward to that stage where we have 9 crew members on board the station. And during the direct handover period, when we have 9 crew members on board, we will be seeing a spacewalk conducted by our Russian colleagues, Oleg and also Sergei. They will be taking out the Olympic torch that we'll bring up on our Soyuz TMA-11M. And then we also will be having a joint press conference with 9 crew members from US, Russia, Europe, and Japan. So it's going to be very exciting.
Where did this idea for the Olympic torch coming to the station, where'd that come from?
It is from the Russian government to launch a torch on the Soyuz because early next year in 2014, Russia will be having Winter Olympic Games in Sochi. So actually I have not seen that torch itself, but I'm very much looking forward to it.
And this is part of the regular Olympic torch relay, I take it, except it's going to someplace unusual.
Yeah, it is very unusual, and I am looking forward to be a part of that torch relay. Space Station is an international program by the 15 countries, and I think bringing the Olympic torch to the space station really fits our vision of the space station, that it is an outpost to expand the human frontier in space through the international cooperation. Olympic Games is an event that people from all over the world get together in one place and extend friendship through sportsmanship and excellence in sports. So it really fits our vision and goal of International Space Station.
Now, as you mentioned, this torch is going to go outside the space station during a spacewalk by 2 of your crewmates. Beyond that, there are some spacewalks that are on the schedule for your mission. And we know, of course, that the schedules could change. But as you know it right now, what is the plan for spacewalks during your 6 months? And who's doing what? And what will be your role during any of those EVAs?
Right now, concerning the spacewalks, only spacewalks that are on schedule are the Russian spacewalks for the preparation and assembly of the MLM module, the multi-purpose laboratory module from Russia. So our Russian cosmonaut colleagues will be wearing the Olan spacesuit, and they will prepare and also conduct the connections related to the MLM module assembly. And the part of that spacewalks will be involving the assembly tasks of the European robotic arm that will be launched on the MLM module. And as an IV crew member, when my Russian colleagues conduct spacewalk, I will most likely be involved in the operation of the pressure equalization valves of the Russian environmental control and life support system to help them for the preparation of their spacewalks.
During the spacewalk, do you just get to look out the window to see what they're doing?
Yes, last time when I flew on board the space station, cupola was not there. So this time, it's going to be a very spectacular view that I could enjoy through the cupola. So hopefully, I can take a lot of good pictures of my colleagues when they're outside.
A couple of times we've made reference to the new module that will still be coming to the space station, the multi-purpose laboratory module, which was going to go on the Russian segment of the space station. Tell us about what that module is. What new capabilities is it bringing to the station? What is it going to add?
The MLM module, multi-purpose laboratory module, the look is very similar to the functional cargo block that was the first vehicle, the component of the International Space Station that was launched on November 20th, 1998. I still remember that. But the MLM module itself, the shell looks like FGB. However, its purpose is mainly for the scientific experiments. And also, it will house an airlock that will be used to deploy scientific payloads to the outside of the space station, utilizing the European robotic arm. MLM module also has a crew quarter, sleep station of cosmonaut, and also it will have a toilet, and that toilet will use a new system similar to the U.S. urine processing system that will recycle the urine that comes out from the toilet to make it back to a potable water. So MLM has very unique and new technologies, and I'm very much looking forward to seeing the new module there.
The payload airlock is a lesson learned from Kibo?
Actually, when I first had the training of the MLM module and then found out that the MLM has a similar concept airlock for the payloads, not for the cosmonauts and astronauts to go out, I really felt the same way. This is very similar approach to the Japanese Kibo module's airlock using the robotic arm. So actually, during our flight, we will be using the Kibo's airlock and also robotic arm to deploy satellites. 3 U.S. satellites and 1 Japanese satellite, which was developed in cooperation with Vietnam. So airlock is now used not only for deploying the experiments, but also it is used as part of this effort of deploying small satellites from the space station. So maybe we can see these kind of new application on the MLM module in the future, hopefully.
Again, we also mentioned a few moments ago that you're going to be commander of the space station for a portion of your mission, for the Expedition 39 portion, which begins after Oleg Kotov and his crew depart in March. And you will be the first Japanese astronaut to command the station. What does it mean for the Japanese people and for their space agency to have a Japanese astronaut in command of this vehicle?
Like the other international partners of the International Space Station, Japan welcomes when a representative astronaut from its own country takes the lead in the space station operation. And as I mentioned earlier, Japan has become a very reliable partner of the International Space Station, successfully conducting research and utilization using the Kibo module, and also 4 consecutive successful launches of HTV coronatory missions, fulfilling our duties for the logistics supply to the International Space Station for the success of the operation of the ISS. So Japan is very happy to have this opportunity to have ISS commander from the Japanese Astronaut Corps. It's a big challenge for me, And I'm just fortunate to be able to learn a lot from my previous ISS commanders and shuttle commanders. I flew on SCS 72 and 92. Brian Duffy was my commander. He's my mentor. And on expedition 18, 19, and 20, I had the American commander Mike Fink and the Russian commander Gennady Padalka. And on the flight, I went up on shuttle SCS-119. Lee Archambault was my commander. On my return flight on SCS-127, Mark Polanski was my commander. I learned a lot from each one of them. They're great leaders. They pay attention to details. They listen well, and they delegate tasks. And they are wonderful communicators with the Mission Control Center folks. So I just want to be like them, and I was very fortunate to be able to experience and learn from those wonderful leaders.
When you change from being flight engineer to commander, does that change daily life for you on board the station very much?
Well, pretty much I will continue the duties that I have conducted as a flight engineer, like conducting experiments, doing maintenance tasks, robotics, operational spacewalk, or any task that I am assigned to. But in addition to that, I will be taking the lead as the point of contact in the communication, daily communication or weekly communication with the mission control centers throughout the world, and also the program management of the International Space Station in a different country. So that's additional work. I just need to make sure that everybody in the crew is in a healthy condition, and safety comes first, and efficiency, and also the happiness of the crew members. I think it's the teamwork is the key to a success in the ISS operation. I would like to make sure that we always work as an integrated team to be able to utilize the expertise, talent, and also enthusiasm of all the crew members that we work with. I'm just fortunate to be able to fly with such a talented and dedicated crew members.
Can you identify what it is about this flight that you're most looking forward to?
Well, it's a very good question. Last time when I flew on board the space station, it was 4.5 months stay. This is a little longer this time, 6 months or a little longer. And the first time to launch and land on a Soyuz spacecraft. And I'm just looking forward to going back to the Earth and to going back to space to be able to see the wonderful planet of the Earth. And 6 months stay is a long duration. And my goal is to be able to fully utilize the ISS asset and participate and contribute to the maximum outcome in the utilization of the space station. And one of the things that I have never had a chance to do in my previous flight was spacewalk. So I have been training many times in the pool in Houston, in Japan, and also in the Russian training facility in Star City. And so if there's an opportunity, we're ready to conduct any types of maintenance tasks, conducting spacewalks. So I'm looking forward to that too.
If I ask you to try to sum it all up, and I'm going to ask, what is it that you think that we're learning from these missions on the International Space Station that is going to prepare us for human exploration of space beyond Earth orbit?
Beyond Earth orbit. Space station is a wonderful scientific lab which can provide a lot of opportunity for us to gain insight and new data on human physiology, to go beyond the low Earth orbit, radiation exposure, bone loss, weakening muscle strengthening, and also visual impairment. There are so many medical, psychological issues that need to be resolved for exploration beyond low Earth orbit. So by astronauts and cosmonauts working in space on a long duration basis, even a longer duration basis than the conventional 6-month stay, we will be able to gain more insight and data on human physiology to be better prepared for longer duration flight, such as to Mars, asteroid, Moon. Had a selection of astronaut candidate that was back in 1991, and I found that article in the newspaper, and at the time this my old dream of flying in space came back when I saw the article, and of course I never dreamed or thought of getting selected. But I was just lucky, and then I made it in, and I'm here now.
I want to talk more about now, but I want to talk about how you got to here.
Okay.
Let's talk about growing up in Japan, your hometown, and what it was like growing up there at the time.
I was born in a city at the time called Omiya. Now it is called Saitama. And that town is located about 30 miles north of downtown Tokyo area. And it is what we call bed town of Tokyo. It has a combination of the small town Japan flavor and also the big city of Tokyo. And I grew up there, went to school, elementary, junior high school, and high school, and has a lot of housing and beautiful nature. I joined the Japan Airlines as a structural engineer, and later on I received PhD from the university after I joined the astronaut program here. But that's the job that I had before I applied for astronaut selection.
So you were already working for your nation's space agency before you were selected to be an astronaut yourself?
Actually, I was an engineer of Japan Airlines for 3 years before I joined the Japanese Space Agency. That was back in 1992. The selection process of an astronaut started in the summer of 1991, and we went through academic exams, medical, psychological screening, also some group dynamics assessment. And 9 months later, after 4 or 5 stages of screening, I was selected to join here in the astronaut training course at the Johnson Space Center. That was in the summer of 1992.
You're one of, actually at this point, only a little more than 200 different human beings who have ever been on board the International Space Station, at least so far. And as you get ready to go back, what are your hopes about how you can use this mission to inspire space explorers of the future?
I hope through our activities on board the space station, we will be able to end. So it's very interesting to see the change in the scope as the days pass by living on board the space station.
You mentioned that you grew up in this area just outside Tokyo and then went to university and ultimately became an astronaut. What are the highlights of that story, of your education and your professional career that led you to this spot?
Ever since my childhood, I was fascinated with the airplanes. I wanted to become an engineer on an airplane. And I studied aeronautical engineering at the university in Japan. And actually, it was when I was in the junior in the university, I witnessed some of those catastrophic airplane accidents that were due to the failure of airframe or the structure of the aircraft. And I noticed how difficult it is to safely operate airplanes. And at the time, I decided I wanted to be an engineer in the structural and the strength of airframe. And that's what I studied in my undergraduate and also the graduate school, to be able to become a structural engineer in the airplane engineering. And after finishing my master's degree in Kyushu University, I joined.
Why did you want to be an astronaut?
When I was 5 years old, I saw on the Japanese TV program that Armstrong and Aldrin landed on the surface of the moon, and that was the start of my longing for space flight. However, at the time, there was no Japanese astronauts in my home country, and only American astronauts and former Soviet Union cosmonauts were the only people who were working outside our home planet. So I thought going to space was something really beyond my reach. And I was very fascinated by airplanes ever since I was a small boy. And I always wanted to become an engineer or pilot to make and fly an airplane. And that's what I aimed for a long time since my childhood. Studied aeronautical engineering and became an engineer. And then after that, Japanese Space Agency as well. And it was one of the places that I like in Saitama is a shrine called Hikawa Shrine. That is located in nearby the center of the city of Omiya or Saitama right now. It's a quiet place with a beautiful pond, and it always gives me a feeling of being at home when I visit the shrine. And that's where I grew up, and I stayed there until I graduated from high school.
It sounds like it may be similar to an American suburb.
In a sense, yes. It's a very crowded area. Tokyo is a really big city, and a lot of people live outside the outskirts of Tokyo to commute, mostly by train system. And so a lot of people living in that area too.
Were you able to pick out Saitama from space?
Actually, I took a lot of pictures of Tokyo area, and I was able to find my own hometown through the scope of a camera. And it's always a wonderful thing to be able to take a picture of your hometown. First time, I tried to take a picture of my hometown, and then a few days later, I tried to take a picture of entire Japan, and then after that, I tried to take a picture of Asia, and then soon I'll be taking pictures of our home planet in general.